6, 1944, over 800 small wooden boats hit the beaches of Normandy. Inside each one, a single diesel engine screamed at 2,100 revolutions per minute, pushing 36 terrified soldiers toward the most fortified coastline in human history. That engine was built by a company most people have never heard of, Gray Marine. And here is the strange part. 8 days after D-Day, the company was sold for $2.6 million, gone. So how does a company go from powering the most important military operation in modern history to being sold off like surplus equipment before the war is even over? That is the story of the Gray Marine Motor Company. And it starts, like most good stories, with a guy who kept failing upward. O.J. Mulford was born in Monroe, Michigan in 1868. By the 1890s, he was tinkering with boat engines in Detroit, which at the time was not yet the automotive capital of anything. It was just a city near a lot of water, with a lot of people who liked boats. In 1892, Mulford and a couple of partners formed the Michigan Yacht and Power Company. They built small powerboats and distributed Since marine engines. By 1902, they had bought the Since Gas Engine Company outright, moved it from Ohio to Detroit, and absorbed it completely. Then things got complicated. Mulford split from his partners. In 1905, he started fresh with Paul Gray and David Gray. They called it the Gray Motor Company. Single-cylinder, two-cycle engines, simple stuff. By 1909, they were building about 7,000 engines a year. Not bad for a small shop in Detroit. Then Mulford made a decision that looked brilliant at the time. He sold Gray to the United States Motor Company, a conglomerate trying to merge Maxwell, Columbia, and a bunch of other brands into one giant enterprise. Mulford became vice president. The future looked wide open. United States Motor Company went bankrupt the next year. So Mulford scraped together $160,000 from investors, bought Gray back, and started over. Again. He dropped the word marine from the name because he had automotive ambitions now. One of his investors was Charles King, who used a Gray four-cylinder engine in his King automobile. Gray also built stationary engines, outboard motors, and even hopper-cooled units for drainage pumps in the trenches of World War I. They called those the Victory Motor after the armistice. But cars were not where Gray was going to make its mark. By the early 1920s, the automotive dream had faded. Mulford pivoted. He put Marine back in the name around 1924 and committed fully to what the company had always done best, converting other people's engines for use on the water. Studebaker 6s, Pontiac 6s, Hercules industrial engines. Whatever block was available, Gray would tear it apart, rebuild it for saltwater, and stamp their name on it. It was not glamorous, but it worked. Fishing boats, lobster boats, tugs, pleasure craft, anything between 12 and 32 feet that needed a reliable engine probably had a Gray in it. The thing about Gray Marine in the mid-30s is that they were good at what they did, but what they did was not exactly exciting. They took someone else's engine, rebuilt it for marine use, and sold it to boat builders, a middleman with wrenches. The margins were thin. The reputation was solid, but local. Nobody outside of the boating world knew who they were. Chris Kraft had taken over the Hercules engine conversions, so Gray switched to Continental blocks. A friend who toured the Gray factory in 1940 remembers seeing Continental engines being reworked on the line. Steady work. Nothing historic. Now, here is where the story turns. Because in 1936, something happened that would connect a small engine converter in Detroit to the beaches of France 8 years later. And it happened because of a relationship that went back 25 years. General Motors had been working on a new diesel engine. The man behind it was Charles Kettering, the same guy who invented the electric starter for cars and founded Delco. Kettering had been obsessed with diesels since 1913. He wanted a lighter, faster-running diesel that could be mass-produced and adapted to virtually anything: trucks, buses, generators, marine applications, the works. In 1930, GM bought Winton Engine Company and Electromotive Company. Kettering started building experimental two-stroke diesels in his lab. Two single-cylinder test engines with 8-inch bores and 10-inch strokes. One went to Cleveland, one stayed in Detroit. The big diesels worked great for locomotives and submarines, but Kettering wanted something smaller. In 1934, GM established its diesel engine division. An engineer named William Crowe, working directly under Kettering, was assigned to shrink the two-stroke design down into something practical. They carved out some space at the Cadillac factory and got to work. The goal was a family of engines, 3, 4, and 6 cylinders, that could be mass-produced cheaply and dropped into almost anything. By 1937, they had it. The Series 71, named for the displacement per cylinder, 71 cubic inches each. An inline 6 gave you 426 cubic inches total. Two-stroke, meaning it fired every revolution instead of every other one. A mechanically driven Roots-type blower forced air into the cylinders and scavenged the exhaust. Unit injectors delivered the fuel. The whole package was compact, powerful, and surprisingly light for a diesel. And here is where Mulford comes back in. He and Kettering had history. They had worked together back around 1911 or 12 on self-starters for automobiles. When Kettering's new diesel was ready, gray marine was the obvious choice for marinization. In 1936, Gray began negotiating for the exclusive contract to convert the 671 for marine use. They got it, and that deal changed everything. General Motors did not just hand over complete engines. They shipped blocks to Gray without oil pans, exhaust manifolds, flywheel housings, oil pumps, front mounts, or cooling systems. Gray had to engineer all of that from scratch for a saltwater environment. They designed a chain-driven oil pump where GM's other divisions used gear types. They fitted stainless steel core plugs in the water jacket areas. They plated the valve springs to resist corrosion. They added marine-specific cooling systems, bilge pumps, and electrical setups. Then they mated the whole thing to a twin-disc 1.5-to-1 reduction gearbox. The result was the Gray Marine 64HN9, an inline-6 two-stroke diesel, 4¼ bore, 5-inch stroke, compression ratio of 18.7-to-1. For context, your car runs maybe 10-to-1. This thing squeezed air until it practically caught fire on its own, which, being a diesel, was exactly the point. Continuous output was 165 horsepower at 1800 RPM. But there was also something called battle rating. Crank it to 2100 RPM, and you got 225 horses. That was not a number you used for pleasure cruising. That was for getting on and off a beach while people were shooting at you. The whole engine weighed about 2,950 pounds, with the gearbox, fuel pump, and electrical system attached, 54 inches long, 29 inches wide, 41 inches tall, compact enough to fit inside a 36-foot plywood boat, tough enough to survive salt water, sand, and combat. Now, the engine had a boat to go in, and that boat came from a man named Andrew Jackson Higgins. Higgins was, by most accounts, a force of nature. Born in Nebraska in 1886, expelled from high school for fighting, and described by colleagues as a fire-tempered Irishman who drank whiskey like a fish. He ended up in New Orleans running a lumber business that failed, so he started building boats instead. The Louisiana bayous needed shallow draft workboats that could cut through vegetation, slide over logs, and beach themselves without damage. Higgins built those. His Eureka model, completed in 1937, drew just 18 inches of water and could run up on shore and pull itself back off without help. That same design caught the attention of the Marine Corps, who had been struggling for years to find a decent landing craft. The early military versions had no ramp. Troops had to jump over the sides, which was, as you might imagine, not ideal when people are shooting at you. Then someone showed Higgins a photograph of the Japanese Daihatsu landing craft, which had been using a bow ramp since the late 1930s. Higgins called his chief engineer, had a mock-up built, and within a month they were testing a ramp bow version on Lake Pontchartrain. It worked. The LCVP was born. Landing craft, vehicle, personnel, 36 feet long, 10.5 feet wide. It could carry 36 fully equipped soldiers or a jeep with a 12-man squad or 8,000 pounds of cargo. The bow ramp dropped, the troops ran out, the boat backed off the beach, turned without broaching in the surf, and went back for more. The empty boat weighed 18,500 pounds. It drew just 3 feet of water aft and 2 feet forward, which meant it could get closer to shore than anything else afloat. And here is a detail that matters. Before the LCVP, the only way to land an army was to capture a port. Ports had docks, cranes, infrastructure. They were also the most heavily defended points on any coastline. The enemy knew you needed ports, so they fortified them. The LCVP changed the math entirely. You did not need a port anymore. You could land anywhere there was a beach. That single capability, getting troops and vehicles across open sand, shifted the entire strategic calculus of the war. It is why Eisenhower could plan Normandy the way he did. Not an assault on a port, an assault on 50 miles of open beach. That only works if you have a boat that can do it. The first military versions used Hall-Scott gasoline engines, 250 horsepower, plenty of power. But the Navy had a problem with gasoline on a boat that was being shot at. Gasoline vapors and machine gun rounds do not mix well. The British were so nervous about it they ordered their Higgins boats with self-sealing fuel tanks. The Gray Marine 671 solved this, nearly the same weight and size as the Hall-Scott, nearly the same power output, but 20 to 30% better fuel economy. And diesel fuel does not explode when a bullet hits the tank. That matters when you are running a boat into a defended beach. By 1940, the Navy had tested the Eureka against everything else available. It won. It was fast, simple, cheap, and almost impossible to strand on a beach. Production of the LCVP started in 1941, and Gray Marine started building engines like their existence depended on it. Because it did. By 1941, Gray Marine was producing 100 engines per day. 100 per day. They needed constant factory expansion just to keep up. Their main plants were on Mack Avenue and at the former Northern Car Plant on Lafayette Street in Detroit. O.J. Mulford had run the company for nearly 4 decades, but his health was failing. His son, John W. Mulford, who had been running a printing business, took his father's place at Gray in 1941. O.J. Mulford died on August 2, 1943. He did not live to see D-Day. If you're enjoying this, hit subscribe. We cover stuff like this every week. Okay, back to it. So let us talk about what made the Gray Marine 671 special from an engineering standpoint, because the specifications alone do not tell you why this engine mattered. First, it was a 2-stroke diesel. Most diesels are 4-stroke. They fire every other revolution. A 2-stroke fires every revolution. That means for a given size and weight, you get more power. The trade-off is that 2-strokes are generally less fuel efficient and harder to keep clean. But for a landing craft, power density mattered more than fuel economy on a long cruise. The Roots-type blower was critical. In a 2-stroke diesel, you cannot rely on the piston to draw in fresh air the way a 4-stroke does. The blower forced pressurized air into the cylinder as the piston uncovered the intake ports. That air did 2 jobs. It charged the cylinder for the next combustion event, and it scavenged the exhaust gases from the previous one. If the blower failed, the engine stopped. Period. Gray Marine specified blower servicing every 1,000 hours, with a full overhaul every 3,000 to 4,000 hours. The unit injectors were another key feature. Instead of a common rail system where a single pump pressurizes fuel for all cylinders, Each cylinder had its own injector that was also its own pump. A cam lobe on the camshaft actuated each injector directly. This was simpler, more reliable, and easier to maintain in the field. If one injector failed, you replaced that one injector. You did not have to diagnose an entire fuel system. Now, the marinization. This is where Gray earned their money. Salt water destroys engines. It corrodes everything it touches. Aluminum, steel, copper, it does not care. Gray had to take an engine designed for trucks and generators and make it survive being splashed with seawater while running at full power in a combat zone. The stainless steel core plugs in the water jacket areas were essential. Standard steel plugs would corrode through in months in a saltwater environment. The plated valve springs prevented rust-induced fatigue failure. The chain-driven oil pump was more tolerant of debris and misalignment than the gear-type pumps used by GM's other divisions. Every seal, every gasket, every exposed surface had to be reconsidered for marine duty. The cooling system was entirely Gray's design. Raw seawater was pumped through a heat exchanger to cool the fresh water that circulated through the engine block. This kept the corrosive salt water out of the engine's internal passages while still providing adequate cooling. Simple in concept. Difficult to make reliable when the seawater intake is being clogged with sand from a beach assault. In 1944, Gray Marine offered 19 different variants of their Navy high output models. Same basic engine, but different ancillary packages, rotation directions, and transmission options depending on the application. Right-hand rotation for the 64HN series, left-hand for the 65HN. Landing craft needed one configuration. Tank landing craft, which used 3 Gray Marine 671s, needed another. The engine's symmetric block design allowed rotation reversal by reorienting the block or swapping camshafts. Here is a number that puts it in perspective. During the entire war, approximately 100,000 GM 671 series engines were built across all divisions. Of those, Gray Marine modified roughly 52,500 specifically for landing craft propulsion and auxiliary power. More than half of every 671 ever built went through Gray's shop and onto a boat that was headed for a beach somewhere. At the continuous rating of 165 horsepower, these engines had a service life exceeding 2,000 hours. That does not sound like much, but a landing craft was not expected to last 2,000 hours. It was expected to last long enough to get soldiers from ship to shore and back, repeatedly, under fire. 2,000 hours was luxury. And then there is the anecdote that says more about this engine than any specification sheet. In 1975, a mechanic pulled a crate up to his shop. Inside was a Gray Marine 671, boxed and shipped in 1943. 32 years in a crate. He cleaned off the creosote, fitted it out, ran it on the dyno, and dropped it into a 50-foot motor whaleboat. Everything fit. The engine ran perfectly. 3 decades in a box, and it fired right up. That is what good engineering looks like. Now, D-Day, June 6, 1944, the largest seaborne invasion in human history. 3,000 landing craft, 2,500 other ships, 500 naval vessels, 13,000 aircraft, 130,000 troops hitting 5 beaches along 50 miles of the Normandy coast. The planning had been delayed twice. Once because there were not enough landing craft. Think about that. The entire invasion of Europe was held up because they did not have enough boats. Landing craft, more than tanks, more than planes, more than any other single piece of equipment, were the bottleneck of the war. The U.S. Navy had 1,089 LCVPs in the United Kingdom. 839 of them were used to shuttle soldiers from transport ships to the beaches. 81 were destroyed on D-Day or shortly after. 55 of those at Omaha Beach alone. The boats were typically carried aboard attack transport ships, put in the water offshore, loaded with troops, and sent in waves toward the sand. Few made it to their planned sectors. Strong currents and the chaos at Omaha pushed them all over the place. But the sector commanders in control craft improvised, directing LCVPs to whatever stretch of beach they could reach. And inside every single one, a Gray Marine 671 was doing exactly what it was designed to do. Getting on the beach, dropping the ramp, holding position while troops ran off, then backing into the surf and going back for more. Eisenhower said it years later to historian Stephen Ambrose. Andrew Higgins is the man who won the war for us. If Higgins had not designed and built those LCVPs, we never could have landed over an open beach. The whole strategy of the war would have been different. Hitler had his own opinion of Higgins. He called him the new Noah. But notice what Eisenhower did not mention. The engine. Nobody talked about the engine. The boat got the glory. Higgins got the glory. The engine just did its job. Meanwhile, back in New Orleans, Higgins Industries had gone from 75 employees in 1938 to over 20,000 by 1943. 7 manufacturing plants. 700 boats a month at peak production. By September 1943, Higgins Industries had designed or built 92% of the 14,072 vessels in the U.S. Navy. 92%. From one company, in New Orleans. And here is something that does not get talked about enough. Higgins ran the first racially integrated workforce in New Orleans, the largest integrated workforce in the entire South. Whites, blacks, men, women, the elderly, people with disabilities, all paid equal wages according to their job function in the Jim Crow South during a war. His biographer said Higgins needed 20,000 workers, and he got them from everywhere he could, out of beauty shops, out of the cane fields. He hired people who owned trucks to transport workers from communities miles outside the city. Local farmers complained to the government that Higgins was stealing their labor force. They responded by smashing every production record in the book. Over 20,000 boats by the war's end. 12,500 of them LCVPs, and then the war ended, and everything fell apart. Higgins Industries was already in trouble before the Japanese surrendered. The government started canceling contracts. Labor disputes erupted. On November 9, 1945, Andrew Higgins liquidated the business, just like that. The company that built the boats that won the war shut down 2 months after VJ Day. Higgins tried to pivot into consumer products, pleasure boats, appliances, housing materials. None of it worked. He formed a new company, but by 1948, most of his plants were closed. Andrew Jackson Higgins died on August 1, 1952, at 65 years old. One of his old factories, though, got a second life. The Michoud plant that Higgins had built for aircraft manufacturing was taken over by NASA in 1961. They used it to build the Saturn V rocket. The factory that made D-Day possible helped put men on the moon. That is not a metaphor. That literally happened. As for Gray Marine, the end came differently, slower, quieter. 8 days after D-Day, on June 14, 1944, Continental Motors bought Gray Marine for $2.6 million. 2 companies had competed for the purchase. General Motors wanted to make Gray their marine engine division. Continental wanted their own marine engine business. Continental won. John W. Mulford stayed on as general manager. But the world had changed. In 1945, Detroit Diesel began marketing the Series 71 for marine applications directly, cutting Gray out of the equation. The exclusive marinization contract that had made Gray indispensable during the war was gone. GM had learned everything they needed to know about marine conversion, partly from watching Gray do it 50,000 times. Now they could do it themselves. Gray was now just another division of Continental, converting AMC and Buick engines for the recreational boat market. The irony is sharp. Gray Marine spent the war perfecting the art of marinizing GM diesels. They got so good at it that GM realized the market was worth pursuing directly. Gray essentially trained its own replacement. The Fireball series of V8 marine engines was popular in the 1950s. Speedboats, runabouts, Century, Lyman, Chris Craft, they all used Gray power plants. Gray offered 22 different gasoline marine engines and 6 diesels by 1959. But it was not the same. The military contracts that had sustained the company were gone. The recreational market was competitive, and Gray was competing against companies that made their own blocks, while Gray was still buying someone else's and converting them. In 1964, Continental reorganized Gray from a subsidiary into a division. Manufacturing was consolidated to Continental's Muskegon, Michigan facility. Engineering moved to Detroit. The identity was dissolving. By October 1966, Continental announced they would stop offering gasoline marine engines entirely, filling only existing orders. A line of marine diesels under the Gray Marine and CMC brands was supposed to continue. It did not last. Around 1967, Continental closed Gray Marine for good, from building 100 engines a day that helped liberate Europe to closure in a corporate restructuring. That is how it ended, not with a bang, with a memo. The Gray Marine 671, though, refused to die. The Detroit Diesel Series 71 kept evolving. V-block versions came in 1957. Turbocharged models followed. The engine family powered trucks, buses, generators, and boats for decades. Detroit Diesel built their 1 millionth engine by 1967. The basic design that Kettering and Crow developed in that borrowed space at the Cadillac factory is still being manufactured today for military applications, 80-plus years later. And surviving Gray Marine 671s are still running in fishing boats, in tugs, in training ships. The California Maritime Academy's training ship Golden Bear had a cutaway Gray Marine 671 as an instructional engine for years. Boat mechanics who have worked on these engines speak about them the way car guys talk about small block Chevys. Simple, reliable, and practically impossible to kill if you maintain them. A few original Higgins boats survive too. One was found in a boatyard in Valdez, Alaska, with its original engine, barely modified, still wearing its armor plate. Another turned up in a farmyard in Normandy. One appeared at the bottom of Shasta Lake during a drought in 2021. They keep surfacing, like they are not quite done yet. So, a company that started building single-cylinder boat engines in 1905 nearly went bankrupt twice, pivoted from cars back to boats, landed the contract of the century, built 50,000 engines that helped win the largest war in human history, and then got sold off 8 days after its finest hour. Bought by a company that did not know what to do with it, stripped of its identity, and closed in 1967. Most people have never even heard the name. The boat gets remembered. The engine does not. But on June 6, 1944, when that ramp dropped and those soldiers ran onto the sand at Omaha and Utah and Gold and Juneau and Sword, there was a 2-stroke diesel behind them, screaming at 2,100 revolutions per minute, built by a company in Detroit that no longer exists. The engine did not care about glory, it just had to work. And it did. And there you have it. The Gray Marine Motor Company, the engine that powered D-Day and then disappeared. If you have ever worked on a 671, or your father or grandfather did, I want to hear about it in the comments. Subscribe if you want more stories like this. We have plenty.